A fundamental part of the engineering design process is to visualize what an end product will be. 3D printing allows for very rapid prototyping. It allows you to really engage with a design, installation sequence, and the safety risks associated with putting it together. You do all of those things early, it leads to far better outcomes. In particular, in the offshore environment, where the teams in the Americas have been doing some experimentation with 3D printing for some of their work, they face a particular challenge with the high cost of installation. At Stones, they looked at a pretty complex activity of putting together large blocks of syntactic foam in a special disconnectable buoy to an FPSO that will be the world's deepest water installation. They realized that the construction sequence of putting together hundreds of syntactic foam blocks was complex. What's the right sequence to put those blocks into a very complex geometry?
Usually you have nothing more than paper drawings and try to describe how best to do the installation work. What we've done is we've actually used a 3D printer, and we created the model in 3D of the structure, and then a model of all 222 components of the foam blocks, so that we could then plan it and make sure the sequence was right to ensure that we did it safely.
Having a model like this in the design process really bridges the gap between design and fabrication.
It's already added value in understanding whether the dimensions are correct and whether we have clashes or not.
It's a great tool to be able to plan the work, execute it, and anticipate the problems and come up with a workaround before the process even starts.
We've already seen benefits at Coulomb in really improving the design of the bolt connections to hinges. Complex activities that affect offshore installation.
We commissioned the Coulomb 3D print to convey to the engineers that were designing the hinge assemblies and to the contractor the complexity of the structure that we're trying to build.
Having a 3D model aids you in detecting the problems. It gives us a chance to sit together as a team, sitting down with the model and detecting any problems that we foresee.
Seeing them in a solid format allows us to see the physical integration between parts and pieces. On the Coulomb project, it's allowed us to predict the potential problems before we even got into the fabrication stage.
When we move to a 3D printed prototype, we can ensure that we've set ourselves up for a successful design, a successful installation, and a successful operation. But 3D printing has an even bigger future than that. The ability to make spare parts, the ability to create new and different shapes and products.
A central 3D printing team will help us to scale up the capability as fast as we can and therefore drive value in the fastest possible way. The role of a central team is really understanding how to create value and to leverage the best practice across the group.
We're just at the beginning of new possibilities in 3D printing and what it can mean for Shell.